So let's say given this diagram here of a guy's motion along a ramp of radius 5 meters, and the question says the guy moves in a 1/4 circle of radius r equals 5 meters. Find his velocity when he reaches the bottom. Assume no air resistance to start. For this motion, the only force acting on him is gravity, which is equal to the weight force. So that means we can use the conservation of energy to solve, where E1 is equal to E2, which means that the energy is the same at every point in the system. So at this point E1 and at this later point E2, they're equal. We can use the properties of the energies at E1 and E2 to solve. Since E is equal to K plus U, where K is the kinetic energy and U is the potential energy, we can write it in this form here where the kinetic energy is equal to 1/2 mv squared, and this terms the gravitational potential energy of the system. So we can rewrite E1 equal to E2 as this. Then if we look at our diagram and we label our 2 points E1 and E2, where E1 is at the top of his motion and E2 is at the bottom, since we're trying to find the velocity when his height's at the bottom, so this is where our point of interest is. We can identify that the height's equal to 5 meters since the question says he moves in a semicircle. So for a circle, the radius is the same at all sides. Now we can identify our variables. So V1 is going to be equal to 0 meters per second. We're going to assume he starts at rest. V2 is what we're solving for. It's going to be the velocity at the bottom. H2 is his final height. Since he's at the bottom, it's going to be 0 meters. Then mass is equal to 1 kilograms and gravity is equal to 9.8 meters per second squared. So this is our conservation of energy equation. We can plug in all our variables we just found and cancel out the zero terms, and we can compute the amplitudes and the units of the non-zero terms. And if we do that, we get this expression here. We can multiply both sides by 2/kilograms to isolate for V2 squared. So we can see that it cancels out the 1/2 kilograms on the V2 squared term. And then on the left term, we're left with this here. Compute the amplitudes and the units. Then we can do a simple square root of both sides, and we get this for the final answer. So this is the guy's velocity at the bottom of the motion. So this is his motion here. Velocity at V2 is going to be equal to 9.9 meters per second. I want to note at E1, the energy of the system is given by this, and we know that the initial velocity is equal to 0. So the energy of the system at E1 is all potential energy at the top, and then at E2, energy is represented by this, and we know that the gravitational potential energy is equal to 0. So at E2, it's all kinetic energy. This means from his motion from the top to the bottom, all the potential energy is converted into kinetic energy as he travels from the point P1 to P2.